So this is going to be everything you wanted to know about quadratic real-life parabola problems that we're afraid to ask. Okay, so I'm going to give you this problem. This is the equation. Height as a function of time equals negative 16 t squared plus 55t plus 85. Okay? Now, I just want you to use the quad program and the vertex problem to tell me its zeros and its vertex. So let's find the vertex first. So go into your vertex program and let's find the vertex of this problem. So we do A is negative 16, B is 55, and C is 85. And you should get some funky fractions. Program, vertex, enter A, negative 16, the gray key, B, 55, and C, 85. And you should get 55 over 32, which if you divide it out, works out to be about 1.71. And you should get 8465 over 64, which if you divide it out, works out to be about 132.26. So what that means is the maximum height is 132.26 feet after 1.71 seconds. You could also say in 1.71 seconds, it reaches max height of 132.26 feet. Just two different ways to write it. Okay? Does that make sense? Okay. Now, go ahead and run the quad program and tell me when it's going to hit 0. So put the same A, B, and C in. And here we're going to do some hypothesizing. Everyone should have gotten negative 1.16 and 4.59. Let's just make it negative 1.2 and 4.6. Is that what everybody got? So when will it hit 0? In how many seconds? Come on, the answer's right there on the board. When will it hit 0? I even put a box around it for you. In how many seconds will it hit 0? When will it hit the ground? What? 4.6? You sure? You sure? Okay.
3.4.
Oh, you're trying to subtract it?
Yeah.
Yeah, well, if you subtract it, it would actually be 5.8, because when you do 4.6 minus a negative, you get positive. So no, the answer's inside the box.
4.6?
You sure?
We can't have negative time.
Ding, 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 ding. That's what I'm looking for. You
Good
can't.
job.
Remember, this is time, right? Yes?
Yes.
We're talking about, something going in the air and going back down to the ground, right? And this is time right here. Time marches on, as they say. Time does not march back, no matter what we try to figure out how to do it. We have not figured out the fountain of youth. We can't go back in time. So negative 1.2 is a nonsensical answer. It makes no sense. So it's going to hit the ground in 4.6 seconds. So why did the calculator give me an answer of negative 1.2? Well, let's go and look at a picture, because that's 1,000 words. What does the number 85 represent? Mm-hmm. Very good. That's the funkiest zero I've ever seen. Right? It's starting at 85 feet. So this might be someone who's standing on a cliff and cliff diving. Right? Of course, I don't think that they'd have to be like Superman to be able to jump up into another 60 feet in the air. But this might be somebody on a cliff throwing a rock in the air. Right? Tossing a penny into a well way below, whatever it would be. But what's happening is the starting point at 0 seconds, 1 second, 2 seconds, 3 seconds, 1, 2, 3. This is time in seconds, and this is height in feet. Right? Okay? So, at 0 seconds, where is it starting? Right here at 85 feet. I'm going to need to erase this and move it. Roots are negative 1.2 and 4.6. Those are my two answers for rejecting the negative. Because think about it, what it's saying is, in 0 seconds, it's here. If we go back in time, is when it would go over there. But we can't go back in time. Even if we did go back in time, it wasn't back there, it wasn't down there, whatever. It's crazy. But that's what it means. This parabola would have to be full like that. But it started at 85 feet. And we can't go back in time, so this whole path makes no sense. Does that make sense? Does it make sense that it doesn't make sense? Okay, good. So, what's happening? And it would be even sharper because actually it's going to go up in the air a little bit. So, 100, 110, 120, 130, 140. So here's 130 and here's 140, right? It is going to go up, and it's going to be in 1.7 seconds. So 1.7, let's say, is right about here. So let's put our line of symmetry up here, right? That's where our vertex is going to be. Does that make sense? And it's going to have to be at 132 feet about. So somewhere about there. There's my vertex. And it's going to hit the ground. Shoot, I have to do this again. This is so much better with a smartboard. Okay, now I'm not going to have to move it again. Here's 4, 5, 6 seconds. I don't need 6, I just need 5. Okay, 4 and 5. When's it going to hit the ground? 4.6 seconds. So about there. Right? Does that make sense so far? So what's my parabola look like? As beautiful as it is, there it is. That's where it starts. Really, honestly, especially with these problems, if you can just do a quick sketch, it makes all the world of difference. So, in this problem, I asked you to find the maximum. Now, you could be asked three different things. You could be asked to find the vertex, which is just this. You could be asked to find a real-world answer. When will it hit the vertex? Well, that answer is 1.7 seconds. What is the maximum height? Well, that's 132.3 feet. When and what will the maximum be? That's this sentence. Right here. That's the whole sentence. Describe the vertex in real terms. That's when you put all this. But if you're just asked when, it's just that. If you're asked how high, it's just that number. Okay? But this graph could help you remember, sketch out, figure out what's going on. Does that make sense? Now, what if I said, where will it be in 2 seconds? What is the height at 2 seconds? Well, think about it. 2 seconds is right here. It's going to be right about there. Now, how do we calculate that? We go and substitute a 2 right here. So we would do 2 squared, which is 4, times negative 16, which is negative 64. We do 2 times 55, which is 110. We do 110 minus 64, which is 46. And then we do 46 plus 85, which is 131. So in other words, in 2 seconds, it's at, what did I just say? 131? 131 feet. Does that make sense? Yes, because its maximum height is 132. And 2 seconds is after it hits its maximum height. So it makes sense that since 2 is a little bit after 1.7, this should be on the way back down to Earth, but not that far. So therefore, it's going to be pretty close to that. What if I said, where's it going to be at 4 seconds? You plug in 4. 4 squared is 16 times negative 16, 4 times 55, do all the number crunching. But you don't have to do all that. If you go to your calculator and type in, turn it on, go to y equals, clear out whatever's in there, put negative 16x, we have to use x, squared, plus 55x plus 85. And then go to your table. Where's it going to be in 0 seconds? 85 feet, right?
Plus 55.
X.
This side?
Yeah, you got to keep that x in there, plus 85. Now go to your table. And where's that at 0 feet, 0 seconds? 85 feet. Where is it at 1 second?
124.
Where is it at 2 seconds? 131, right? I did that in my head. Where is it at 4 seconds?
49.
And look at this. Doesn't that perfectly look like 49 feet right there? Okay, so I flubbed it. But that makes sense. If you use a drawing, you can see how it maps out that the numbers make sense. Now, here's the bonus question. When will it be at 110 feet? Well, now we got to do some manipulation with the original equation. Where does the 110 go? That's the initial height. I want to know when will it be at 110 feet. Where's height? In the front. Isn't this height as a function of time?
Yes.
So what we have to do is do this. 110 equals negative 16t squared plus 55t plus 85, right? Now let's just look at our drawing and hypothesize. Where's 110 feet? 100, 110, right? Well, where's that going to be? It should be something less than 1, right? With this excellent drawing. And something probably pretty close and hopefully under 3 if my drawing is anywhere close to being right. Right? But when I calculate this, it should be about 0.8 and 2.9. We're just going to guess. We're hypothesizing. Let's see how close we are with my horrible drawing. Now, before I can solve this in the calculator, what does this have to be? What number? Starts with a Z and rhymes with hero. 0. This has got to be 0. So I have to move this bad boy over here. So I'm going to subtract it. Which gives me 0 equals nothing changes here. Nothing changes here. The only thing that changes is what's 85 minus 110? Negative 25, right? So now I'm going to run not my vertex program, but what program am I going to run? Quad, because I'm trying to find my x-intercepts. And what I'm doing isn't that a horizontal line? Right? That's my new x. That's my new x-axis. I can move this line anywhere I want, up and down. Right? So now I'm just going to change my c to negative 25 and run the quad program. So I'm going to put in negative 16, 55, and negative 25. So you go to your quad program, enter, enter, and you put in negative 16, 55, and negative 25. Okay, well, my 1 is really good. What'd I guess? 2.9. What is it? 2.89. Dang, I'm good. This one was a little bit worse. This should have been more over here at 0.53, 0.54, right? But, you know, I'm not an artist. So, what does it mean? When will it be at 110 feet? In half a second, right? And just under 3 seconds, 2.9. And this is the beauty of having this picture. You can do this all day long. When will it hit 90 feet? You just do this, right? And guesstimate. It's going to be really close to 0, like 0.1, 0.2. And it's going to be maybe about 3.5. So what do? Watch. We plug 90 in. We subtract 90. What's 85 minus 90? Minus 5. That's our new C. So go to your quad program. See how much fun this is? Go to your quad program. Enter again. It'll give you, put you right back into the program. Do negative 16, 55, and negative 5. You should have gotten 0.09 seconds and 3.3 seconds, which is kind of what we estimated, right? Really close to 0 and close to 3.5. That's the beauty of this. You keep just moving this line up and down, right? And you just test your x-intercepts. How about this? When will it hit 140 feet? Well, you plug 140 in here, right? What's 85 minus 140?
55.
What?
55.
Negative 55?
No, just
85 minus 140?
Yeah, sorry. Yeah.
Negative 55. So go ahead and do it again. Negative 16, 55, and negative 55?
Yes.
Yeah. What happened? What'd you get?
The error.
The error. Why'd you get an error? There you go. It's higher than the maximum. Didn't we say the maximum was down here? If that's the maximum, how can it ever hit 140? It can't. So that's where the picture saves you from entering in the calculator. You don't even have to waste your time. It's a trick question. When will it hit 140? It won't. Now, what if I said, when will it hit 20? What two types of answers are you going to get? What kind of answer are you going to get? Here's 0. A negative, right? You're going to get a negative and something around 4.6, 4.5, right? So if you put 20 in here, which you just subtract 85 minus 20, what is that? 65? Run it again. Second, quit, get out of your error. Go to your program, go to quad, put in negative 16, 55, and 65. Negative 0.9, right? Which we throw that out, and 4.3 or 4.4, which makes sense because it's going to hit the ground in 4.6 seconds. So 20 feet above the ground should be pretty close to 4.6, and it is 4.4. And there should only be one answer because it started at 85, so it's only going to hit the ground, one time. Go away. Mute. It's like something at the magic house, a picture within a picture within a picture. So does that make sense? So this is everything about a real-world quad program. You can be asked to find the maximum. You can be able to find the height given a time, which you just plug in, which you can just use your table. Or find the time given a certain height, and that's your quad program. So you got to be able to understand the difference between the two programs and what it's doing. But that's why the picture really helps keep it on track. This is an x-axis. This is an x-axis. And whenever you're finding the intercepts, you're finding the roots or the solutions or the x-intercepts. That's why I said it's really important to know that those words all mean the same thing. So you're going to use the quad program every time you're trying to find time, right? You're trying to find the x-intercepts. And if you're trying to find the maximum, you're using the vertex program.